what makes an Angular component smart, what are differences between smart and dumb components. Smart component will not be there for presenting data. It's all about the distribution of data and passing the events to the services which will handle data processing. That's why in our smart component, we'll not be focusing on fetching data, we'll be focusing just on navigation. We can use NgRx Store library to store data globally. Ultimate approach, which will be presented here, is heavily based on the RxJs and using the view child. Hello, everyone. My name is Tomasz Borowski, and for the next, I guess, 30 minutes, we'll be talking about your smart components and what approaches we can have in implementing them, because there are a lot of them. So in this presentation, I would like to show you what makes an Angular component smart, what are differences between smart and dumb components. We'll go through the real case scenario, which will include the view for displaying the space launches of SpaceX, to see different approaches for implementing smart components. We'll use the most basic one, which will be based on the single service from which we'll be reading data without actually observing too much. We'll see the resolver case. We'll go through the extensive using of observables. We'll take the experience that we had from the David's talk to see how we can implement that in signals. And we'll also take a look how we can implement smart components with NgRx Store, and at the end, we'll see the ultimate solution that will be probably the best from all those listed here. So this presentation and all the examples are available as an app. You can go to the smart.angular-in-space.pl to see this and to play around after this talk is over. Okay, so what is actually a smart component? So smart component is usually the top level component that is connected to the Angular route, and it's the component that injects the Angular services like our data services or store or activated route, and smart component gets data from those sources and delivers this data to the presentational components, which accepts those data through the input mechanism. And in this case, in this example, such a presentational components would be list component, filters component, and the pagination component. Those components are meant to display data, and if they need to change anything about the state of the data in the application, they do not do that by themselves, but they use the output mechanism to let them know, the smart component, that something has to be done with the data. So they actually can request sorting, filtering, or changing the page. Smart component will not be there for presenting data. It's all about the distribution of data and passing the events to the services which will handle data processing. In many articles on the web, you will see also another name, which will be container for these smart components, as this component basically contains other components. The reason for doing such an architecture is that we have an only single point of contact with the data providing services here in the smart component. And this data flow from the top to the bottom will allow us to improve performance by using on-push change detection strategy within the presentational components. Okay, so let's go through the example. So here are requirements that I had when I was implementing these examples in different approaches. So we have the list of the space flights of SpaceX. We support data filtering with this filter component. We display the status indicator, so we know if data is being loaded or is there any error. And we can use pagination to switch pages, and we can see the total number of results that are there on the API side. This application is accessible in the URL that I mentioned lately, and it's also accessible on Staglitz and on my GitHub repository, so you will be able to find it details there. So let's see what approaches we can have. The first simple approach is the one that every one of us, when they were starting with Angular, were implementing. And it's just injecting all needed services to our component and then grab all the data we needed. So let's see how it looks. Here is this simple approach. We can filter data, we can paginate it. We can see this loading indicator here when we change anything about filtering or pagination. We can enter error phrase in search to cause an error. That's the secret phrase that does it. So at the first glance, it all works. But how it's implemented? We can use in each of those examples the show source button to see the most important parts of the code related to the given approach. So in the service-based approach, I just connect our smart component to the Angular router, nothing special here. But when we see this component in action, we see that it injects all required services, and then it defines the state we'll be using in template by 4 properties. First property is params, which will hold parameters used for data filtering and pagination. Then we have launches property, which will contain the list of launches to be rendered. Then we have a status property. So it could be an idle state, it could be an error status, or it could be a loading status. And there will be an information about total number of results that are there on the API level. So there might be more data than is actually rendered. It's due to the pagination. So yeah, here I'm using ng-on-init lifecycle hook to start with loading launches, and I use snapshot from the activated route to read query parameters, because one of the requirements I was also having in mind is that all those parameters, so for instance, if I search something or paginate, will go to the URL. So we can actually copy this URL, pass it to someone else, and the other user will end up in the same place in the list. I think that for the listing views, this is very useful feature. We should not forget about it. Okay, so going back to the sources, here I call the getLaunches method. I use a function called queryParams to launchParams, which maps the query parameters from the URL to the parameters that will be accepted by the service, which will be fetching data for us. This method will be used in every approach as a mapper that provides that mapping of parameters. So getLaunches function does a lot of things, which is not great, but it works. So it sets parameters, it sets status to loading, and then we start making an HTTP request with the launch service and the getLaunches method. So This may result in having a new data. So that's why I'm using here the tab operator to switch the status to the idle again, because the request is finished. And in case of error, I'm switching to the error status. And as I don't want to present invalid data in the view in case of error, then I'm using the catch error operator to return an object which will have empty data list and total set to 0. And finally, this object, or the one returned by the get launches function from the service, will be used to set up the launches list and the total. So these properties, params, status, launches, and total, are used as an inputs to the presentational components. We have 3 of them here: the filters component, the list component, and the pagination component. This will be presentational components that will be used in all of the approaches I will present. So if we need to do any filtering here, or we need to change the page, we are using the outputs to call filter launches function or page launches function in our component. And as you can see, it does 2 things. One, it navigates. It is updating the query params in our URL. So if I refresh page, I will end up in the same place I was. And the second thing is, again, calling and launches here to fetch the data I want. So that's all. It's not that complicated. It has a reasonable amount of code, but it could easily turn into mess if we go with many more features that could be added to this list. So pros for using this approach. This is very basic approach for newbies, definitely, because we don't need any knowledge related to RxJS or signals here. So it's easy to get started. Data is stored within the plain properties, so it's easily accessible, no subscribes, which would make this a bit more difficult. But from the cons, we are using here declarative approach. So the state is defined manually. We retrieve the data and we have to set this property, that property, and so on. And if we miss something, then we have some troubles in our state, some inconsistent data. Another con is that everything is defined here in one place. So as I said, it can be turned into mess pretty easily. So this is first simple approach. Let's see another one. Another one will be based on the resolver functions. So we can actually use Angular resolvers to move fetching data from our smart components into those resolver functions. So this by default is based on the handling parameters from the URL. So each time we'll change some query params in the URL, such a resolver will be executed and will deliver data to our smart component. It could be delivered in 2 ways. First, through the activated route object, which exposes data observable. But we can also use the new feature that was added in the Angular 16 version, which is component input binding. And resolver can deliver data to our smart component through inputs, as we will see in the example. So let's see it. Let's see if it works. CRS again. Let's change the page. Okay, it seems that it works. we can see updated parameters in the URL. So let's see at the source. So in order to start working with these component input bindings that were added in Angular 16, in the router configuration, we need to call with component input binding method, or if we are implementing the module-based application, there is an option called bind input to component or something like that. I would need to check the documentation. But it's available in both cases. So having that, we can start changing the configuration of our route. We have here the smart component connected to this route, and we need to define the property called run guards and resolvers and set the value to params or query params change. That means that if any parameter of the route or query param is changed, then all those resolvers have to be rerun by the Angular. So that's why in our smart component, we'll not be focusing on fetching data, we'll be focusing just on navigation, and this navigation will cause running resolvers that will provide us with the new data. So let's see how these resolvers connected to the resolve property looks like. So here I have an object which actually exposes functions that are also available here from the Angular 15, I guess. We can implement resolvers as a functions, much simpler than the class-based approach. So first resolver called params is taking query parameters from the activated route snapshot and maps that query params to my launch params that will be needed in the view for the filter component, and that params will be also needed for fetching data here. So second resolver here is the launches data, and this resolver also works with the activated route snapshot, but it also injects the launch service, as we can use inject function here to use the service. So I'm calling the get launches function, call this resolver here to have not just the query params, but the params that can be passed to the get launches method. And I exposed both to resolvers in the launch resolvers object and connect that to the resolve property on the route. So that will handle data fetching and providing the params to the view. So let's see how we can read it. So I'm using this component input binding feature. So in my smart component, I have two inputs, params, which will hold launch params, and I have input called launches data, but I'm using here a setter approach because I don't want to store just launches data. I'm using this setter as a distribution point to take data and total and pass it to the launches and total property, which are defined here. As I mentioned earlier, filter and launches and page launches functions that are used for handling outputs from the presentational components are focusing only on navigation. We do the navigation and the rest of fetching data is handled with the resolvers. Here in the navigate function, we can also work with the status property. Because we are fetching data somewhere else, we can actually mark this loading state as based on the navigation, because within the navigation, which will take some time here because we are using resolvers, we can at the start mark the status as loading, then try to navigate, and when this navigation is successful, then we'll, based on this promise, set back the status to idle. And if navigation fails, and it will fail if any of the resolvers fail, we can catch that issue, catch this error, and set status to error and clean the list of launches and set total to 0. So to show you that it works, I will also type error here, and yes, loading is failed. Okay, and that's it. Not that much code here. So let's see what are the pros and cons of that solution. So again, with this computed input binding, component input binding feature enabled, still no knowledge of RxJS or signals is required, so it's easy to get started. Data is stored still in the plain properties, so it's easily accessible. Fetching logic is moved out of the component. It's in the resolvers, so that improved a bit the readability of our component. But we have to keep in mind that if a resolver fails, then navigation is cancelled. So we can, for instance, not enter our smart component if we were in the different place in the app. And we can leverage the reactive approach when we not use the component input binding, but rather use the activated route object and its data observable. From there, we can use RxJS operators to fetch the parts of the state we need. So that's the pros and cons for the resolvers. Up next is RxJS observables and using async pipe within our templates of the components. So here I will add additional element to this whole picture, which will be a component provider, a middleman service, which will handle requests from the smart component and translate them into the actions to the services we need. And it will expose the state through the observables. So the smart component would be much cleaner, and all the business logic would be hidden in such a service, which will be delivered, which will be provided on the components level. So let's see how it works. We have this RxJS Async approach. See if it works. It's still working. Nothing changed from the yesterday. I didn't break anything here. So let's see how it looks from the code point of view. Nothing special regarding the route definition. And let's see now the async-based service. So this service in the middle. It injects all the required services we'll use, and it exposes status here as a behavior subject. So the initial value here is idle. I'm using in the line 20 the activated routes query params observable to fetch information about launch params. Here I'm observing query parameters and map them with my query params to launch params method. But that's not all. In the line 24, I'm reusing these params observable that I defined in the line 20, and I'm going further. I use debounce time here to delay a bit requesting data in case query params would be changed very fast. Then in the tab operator, I'm switching the current status to loading, and I'm using switch map to switch to fetching launches based on the given parameters. If it succeeds, I'm switching back to the idle state. If it fails, I'm setting the error status, and I'm catching that error. At the end, in the line 36, I'm using the share replay operator to multicast the data fetched through this service. So when I will have the more subscribers for the launches and totals, which are using the launches data defined here, they will not cause additional HTTP requests. So in the line 39, I'm defining the launches observable. It takes launches data and just picks data from it. The same goes for total. It picks up the total property. And we have here two functions, filter launches and filter and page launches, which change the parameters for that view by causing the navigation. And if we navigate here, the new value for query params will appear in this observable. So again, every observable will be here recalculated reactively. So that's it in this middle service. So let's see at the smart component. It injects the async-based service, and it just takes references to previously created observables. So params takes params, launches takes launches, and so on. We have filter launches function here and page launches that pass parameters that were provided through the outputs to our middle service, to our component provider. So in this implementation, such a smart component is clean and all the logic is moved to the async-based service. Since we are working with the observables here, we will use async in the template. So we don't have a manual subscriptions in the components class that we would need to take care of in case of unsubscribing. So we are using async here. And one, let's say, issue with async is that it in typing, it assumes that the result of the subscriptions would be, in that case, params or null. And I, as a creator, know that there will be no null here. It cannot be, because I'm all based on the query parameters. And this is the type of the observable that emits value upon subscription. So we'll have data for params instantly. Same will go for the launches and total, as I use here start with operator. So I need to use here exclamation mark, which is non-null assertion operator. And it tells Angular that I know what I'm doing and there will be no null here. That's basically it. Okay, so yeah, async here, async there, async everywhere in that template, and it works. Okay, so let's go to another example. Or maybe before that, let's see the pros and cons of this RxJs observable concept and using the async. So finally, we have reactive approach. So state is derived from the view params. State management logic is completely moved out of the component. We are using RxJs operators, so each observable is very easily extensible. There is this one issue I mentioned about using the async pipe and the null case. And one drawback here is that we are using observables, so we cannot easily fetch data like synchronously of the observable to see what's the current value. I mean, it's possible for the behavior subject, so we could also instantly check for status value in that case, but all other properties or other observables would require subscription. So that's the one drawback of using observables here. Next one, signals. This will be very similar to the RxJs approach. We'll have this service in the middle again, but everything will be based on signals. So let's see if it works at the beginning. So again, maybe now let's search for Falcon. There were some missions related to the Falcon Sat, Falcon 9 test flight, Falcon Heavy. Okay, so that works. Pagination works. Handling errors works. Okay, so let's see the source. Nothing special about the routing here. All the goodie is inside the signal-based service. So again, we are injecting all those services we need. And we start by making a query params signal. And here I'm using the toSignal function from the RxJs signals RxJs interop module. So that converts observable into signal. And I'm using here a flag called requires sync set to true. That basically means that this signal will have value at the beginning because the query params emits upon the subscription. So we'll have this value immediately. Then I'm using this signal in, for instance, line 23 to describe the computed signal called params, which is using my mapper and maps the router query parameters to my launch parameters, my launch params. In the line 21, I'm using the writable signal that will hold the current status. At the beginning, it's idle. In the line 25, I'm defining another writable signal, which will hold the info about the data and the total. And that one is a bit tricky to handle. Because I will use parameters and HTTP requests to fetch the data, I needed to introduce an effect, and signals effect that will react upon the params change. So in that case, when the params are changed, I'm setting the status to loading, and I'm making this HTTP request, updating status after this request. And upon subscription here, when data arrives, I'm writing new value to the readable signal, which is launches data, and set it to the result of this request. And that's not available by default. If I remove that configuration here in the options, okay, I forgot it's not editor and I cannot edit the static page. Sorry. If I would remove this configuration, basically Angular will find out that I'm setting data, setting other signals within this effect, and it will scream with errors at me. Because according to the documentation, effects should not be used for defining values for the signals, as it may result in some errors. Even this famous one, expression has changed after being checked. But this is the easiest way to handle this HTTP request case based on the parameters, and it works without raising any errors. So there is this option for some purpose, and I'm using that purpose. Okay, so as a result of this HTTP call, I'm setting this launches data signal, and this signal is used by the computed signals here, launches and total, which basically picks data or total properties from this launches data signal. Again, filter launches and page launches are focused only on navigation, and everything starts from changing route params. Okay, let's see how it's used in the component. So again, I'm injecting the signal-based service. I'm passing the references to the state parts I'm interested in. So this looks like the thing we did with the RxJS approach, but the biggest difference is here in the template. We are not using async pipes, we are just calling those signals, and it's there. The current value of each signal is being delivered to the input of every presentational component there. And it works pretty smoothly. So to summarize this approach, again, we have this reactive approach. So state is derived from view params. State management logic is still out of the component, which is nice. Another benefit is that signal can be called for current value as a function without parameters. So this is very easily accessible. And as a cons, maybe this non-trivial integration with parameterized HTTP requests. It can be done in the effects. On the other hand, we can read in the documentation we should not do that unless we are pretty sure what we do. So we have to be sure what we do and do that. So that's the new approach with signals. Another approach we can take is the heaviest one from all of things we already seen. So we can use NgRx Store library to store data globally. We can call actions through our components to cause data changing in the reducers by the reducers on the store. And those actions can also cause some effects that will be able to work with our data services. So let's see how it works there. We have this NgRx Store to show you that this is actually NgRx Store. I'm going to open the Redux DevTools. So as you can see, I have my application opened. The first action here related to launches was load, and it loaded some data because of the running effects, and the result of it was stored to the store. And if I want to use pagination here, for instance, show the second page of the results, I'm calling the page action, which calls the navigation here. I'm using the NgRx router store library. And this will cause the calling of the load action. All right. So let's see how it looks from the code perspective. So the setup is heavy, as I said. We use all of the goodies that are provided related to the store from the NgRx. So here I'm providing the store. I'm providing the router store, as I wanted to track the routing actions and use router selectors for fetching the query parameters data. I'm using effects, and I'm using the store DevTools, so I could have better experience with debugging. So nothing special about the main route here, or is it? I'm using here load children. One of my requirements here was to lazy load the entire reducer and the effects related to the launches. So I did a global route called store, and underneath it loaded with the lazy loading the new collection of routes, which was basically the empty route that was using the stored base component, the smart component. And here I'm with the providers registering the launches reducer, and launches effects. So thanks to that combination, it could be lazy loaded. Let's see the actions definitions. So here I'm using the helper called create action group to create actions related to launches, and there will be 5 actions here. The load action that would accept the launch parameters, the load success that will have response data in the payload, the load error in case fetching data will fail, and filter and page actions, which will have parameters related to the launches filtering or page settings. In another file, I'm using create feature helper to create both reducer and selectors related to my launches feature. So I'm providing here the name of the feature, and in the reducer property, I'm creating a reducer with the create reducer helper. So I'm also using here NgRx entity adapter to have methods that would help me with data manipulation, and adapter also will provide me some built-in selectors that I will be able to use. So here I set the first parameter the initial state, and then I will handle actions. So first action I will handle is load. When load is called, I'm setting the status to loading. When load success is called, I'm storing the information through the adapter about fetched data, about space flights, and I'm setting the status to idle. And on the load error action, I clean the table of the launches, and I set error as a new status. In the line 30, I'm creating additional selectors that will be used by this feature. So here I'm using the getRouterSelectors method. It's provided by the NgRx Router Store and gives us selectors for the params, for the query parameters, for the fragment from the URL, all the stuff basically you would get from the activated route. And then I'm returning object of additional selectors, which will be the ones provided by the NgRx entity adapter, and one mine selector created by hand, which will be select params that will use mapping from the router query parameters to the launches params. That are not all selectors, because this create feature function already creates dynamically selectors by the initial state. So if I have these data total or status properties within the state, it automatically will create selectors called select data total or select status. So a bit of metaprogramming is done there. So here we have defined selectors and reducers, and finally we have effects. Here I'm using the new approach, functional effects that were added in the NgRx 16, which was released just right after releasing Angular 16. So here in the create effect method, I can provide a function that does injection in the parameters. And then in the handle params effect, I'm listening for action called router navigation action. This is action provided by the NgRx Router Store. So I can catch here the navigation actions, and there in the line 15 is one line that I don't like that much, but I had to do this because I was interested only in navigating within this view related to the store. So only this navigation here, not going to signals or somewhere else. Okay, so I filtered additionally those events here. And with this payload I had from this action, I used a switch map to switch to the current parameters taken from the select params selector and cause another action, which is load, passing those parameters that are needed for data fetching. This load launches effect is defined a few lines below. It injects also the launch service. So I'm here listening for the load action. And when it happens, I take those parameters from the payload and I make the HTTP request for launches. If it succeeds, I return the load success action. And if it's not successful, I'm using the load error method. And I have two additional effects defined here related to filtering launches and changing page of launches. They are basically making the navigation. Here, they are not dispatching any further actions. So, a lot of boilerplate to start with, but finally, let's go with using that. So in the smart component, I inject store, and from the NgRx 16 version, I have this function called select signal. So I can use previously created selectors to provide a signal in the smart component. I can use an observable approach by using a select function, but I can also use, as you can see, select signal. Then I use those signals within the template, so no using asyncs anymore. We can use signals and it looks much better. All right, so that's it for the RxJS approach. Let's see pros and cons. So we still have this reactive approach which we really like. State is derived from the view params. We have a very standardized solution. We have actions, effects, reducers, selectors. So if our team is familiar with the concept, they will be it will be much easier for them to understand with those elements that they are already know. We have a great support from the store DevTools, which makes our debugging easier. Selectors support observables and signals. And one point is that it requires a lot of code, as you've seen. So this is like, it could be, we can look at it as a drawback, but I look at it like a consequence of choosing this approach. Okay. And that's all from all the, let's say, normal approaches. We have last one, which is ultimate. Ultimate approach, which will be presented here, is heavily based on the RxJS and using the viewChild decorator to fetch the instances of the presentational components directly into the smart component class. So let's see if it works at the beginning. So let's search. Okay, search works, pagination works, error handling works. Okay, looks nice. So let's see how this is implemented. Nothing special in the route definition, and all the magic is defined here in the smart component. Actually, this component contains no methods. It just exposes one property called state, and it has all we need. So here I'm using viewChild to get the pagination component and the filters component, which are rendered there. And here in the ng-on-init, when we have access to those presentational components, I'm making this huge observable. So we want to trigger an event at the beginning, and then on every emission of the event from the filters, from the filter component on the paginator component. If filter output or page output emits a new event, we cause the navigation. And when this navigation is done, we are using a map operator to map new query parameters taken from the route snapshot and map it into the launch params. Then we take these launch params, and in the switch map, we are making the request for launches. And then in the result of this operation, we expose the new state here with the params, launches, new total, and the status. We handle the errors if they arise. And we have here some start with operator to provide the initial state when the data is starting to being loaded. And we are using share replay again here, operator, to multicast this observable. So these 5 subscriptions that I did in the template will reuse the same data provided by the get launches method. So it's all done within the single observable. So we have this reactive approach that is derived still from the view params. We have the smallest amount of code from all these approaches we've seen, but is it readable? Maybe not. Maybe it's only understandable for the RxJS wizards. We have to think of that the working solution is not the only criteria of a good solution. We need to focus also on providing things that will be easy to understand for other developers. So this ultimate approach is implemented for fun to show you that we can do a lot with the RxJS, but in the real life, I would not use such an approach. Finally, conclusions. So I have to say that there are no best approaches. We have different approaches. You can choose whatever you like, whatever is most suitable for your project, for your team, because if you want to implement an NgRx Store, it doesn't mean that your team wants that and will have this willing to understand and learn NgRx. However, there are best practices which you can follow at any time. It's don't repeat yourself, keep it simple, separation of concerns, and so much more. So each approach is different, and it's up to you to select which one works for you. Another conclusion that it's taken from this implementation of examples is that signals are very great, have a great potential. We know that it's still under development, so there are still missing parts. Some parts are confusing. RxJS is here for long. It will be here for long, but I can imagine that signals in the nearest future will be upgraded, still developed, and in some point it would be a very good standalone solution that could be used with RxJS or without it. Okay, that's it. Thank you for your patience. As I said, you can access this app online. We'll post the link in the comments soon. And if you want to learn about me more or my workshops, you can go into the Angular in Space PL website. Okay, that's it. And do we have any questions here? I see that there were discussions about Setters. Presentational component versus setter. This is something that I was mentioning on the second slide, or the third one. So presentational ones use inputs and outputs to communicate with the world, and smart components, also known as containers, they are using services to fetch data or to delegate data modifications. Yeah, some authors call that smart components pages. Someone else calls it view. In some articles, we could also see controller name. So it has a lot of different names. Yeah, another way to use content projection to pass data to our child component. Child component can use the ng content tag to accept some markup that is provided by the parent. It could be used through the content child decorator, so we can actually read that content, but for the passing simple data, I guess inputs are the most suitable solution here. Yeah, functional guards are also possible instead of class ones. The class ones are already deprecated. Danish asked if this will be available for watch later. I hope so. It's recorded. We'll see. It would be helpful. Yeah, live streaming, it will be available on YouTube. So, okay. The answer was in the next comment. Yeah, we can use retry operator to retry the HTTP requests upon failing. Sure. Adrian asked for the Signal example. What if I don't need the response data anymore? Do I need to implement some take until or restore to default feature by myself for signals? No, take until is only present for the RxJs observables, and in case of this, my example, we have only one subscription here in the effect, and it's only an observable which results in the single event, and that basically it's it. It closes the observable and completes that. So there's nothing to unsubscribe from. And no further questions. Okay. So again, thank you very much, and have a good luck on your projects, and hopefully you will find something useful from this presentation and implement that in your project. Thanks.